But if you take a 20-year-old C++ program or 15-year-old and compared it with a re-engineered piece of code in just about any language, you will find that there's many more vulnerabilities in the old style code than there is in the new language code. If you have new C++ code, you wouldn't have those vulnerabilities either.
Hi, Bjarne. Welcome to Software Engineering Daily.
Hey, thanks for having me. See how things work.
So, from the opinion paper that you and several colleagues of yours have put out very recently, I would love to quote something. But we must evolve. Now, before we move on to the context of that statement, let's address a bit what took you and your colleagues to make that statement and then opinion paper, right? So let's kind of address the elephant in the room. So it seems like many, in this case, governments and also private organizations are pushing very strongly for the industry to move away from programming in C++. They are considering it a dead end and a no-go zone sometimes. So these are very strong statements. I'll quote them, by the way, so that I'm not paraphrasing anyone. Especially those organizations and individuals in the security industry are calling for new generations of developers to not use and learn C++. And to those already using it, to stop using it and switch to memory-safe languages. And I quote now, these vulnerabilities, ones that are, the reference are to many studies by Microsoft, Google, and other organizations, a long list of them, and many others are made possible because C and C++ are not memory safe. Organizations which write large amounts of C and C++ inevitably, and that might be key to our discussion now, inevitably, produce large numbers of vulnerabilities that can be directly attributed to a lack of memory safety. These vulnerabilities are exploited to the peril of hospitals, human rights dissidents, blah, blah, blah. Using C and C++ is bad for society, bad for your reputation, and it's bad for your customers. End quote there. So very, very strong statement that is directly attacking the lack of memory safety features in C++, I would argue. So let's start there. Let's focus on the design of C++, if you don't mind, around the lack of memory safety features. Was that something that was done on purpose back in the day? And I'd like to start there.
So you raised a lot of issues around the central topic. And some of those statements were very strong. And I was very tempted to make some very strong statements, but I won't. We'll let other people hype, and I don't. So C++ has been evolving from day one. It was a design choice back in about 1979. Because I realized that there was no way I could build a perfect language from scratch. I didn't have the resources, I didn't have the knowledge, and the world changes all along. And anyway, good engineering relies on feedback. And you only get feedback by building something, trying it out, first for testing, but then with friendly users, and then at scale. And you always learn something. And then you go back and you rebuild, reorganize, rethink, and come up with something better. And we've been doing this for decades now. And we'll keep doing that. Then coming to safety, I've always aimed for complete type safety for C++, complete type and resource safety. You can find those ideas documented by me back in the 90s. It's just harder to get there than people think. I was the main author of the Joint Strike Fighter coding guidelines, which made certain forms of software rather safe and reliable. C++ is essential in many areas and very reliable. Um, can't send repairmen to space when a satellite doesn't work, etc. And C++ is very widely used there. So you can use safe C++. And for the last about 7 years, I've been working for the C++ core guidelines. That is a set of rules that allows you to write provably safe C++. And to get to that, you have to think a little bit. I like and prefer static type safety. That means that you can prove that either something is safe or a runtime check has been put in place.
Yeah.
For something like C++, that cannot be done if people write arbitrary code. It's impossible. You're up against the halting problem. So to make this work, what you need to do is to have a set of rules that limits the use of the language to things that can be proven safe. And to make that feasible, you need some library support so that people don't have to spend all of their times in the dark corners of the language. Now, one thing that really annoys me with some of these comments about C and C++ is they keep talking about C/C++.
Yeah.
That is a mythical language and not one that I like. And I propose and promote a much stronger typed style of C++ straight from scratch. And then I want that validated by static analyzers. And the static analyzers that you get for the core guidelines, especially from Microsoft, but also in Client-ID and such, they come pretty close to guaranteeing it. That is, we can make sure there's no memory leaks. We can make sure that there's no dangling pointers and things like that. That means that there's some things you can't do, like quite a few dirty tricks. And it also means you have to rely on some trusted libraries, like a thing like span that guarantees that you don't do buffer overflows, you don't do out of range access. And these things are available. And if you look at any language claimed to be safe, they also rely on things like that. So it's not that different. And my recent work for sort of eventually standardizing these techniques says that we'll probably have to have some unverified code fragments, just like every other language that claims to be safe. And it's the languages that claim to be safe and they don't have unsafe areas has another solution. It's called core C or C++. And we can't do that. That would be cheating. And so we have to be explicit about what is safe and what isn't. And by default, when you pass the static checker, it'll be safe. Some of my recent work goes a little bit further about that because we've been thinking about it for a while. And that is that different people, different organizations, different industries have different definitions of safety. So I have a paper together with Gabidas Reis, who I've worked with for a long time on some of these things. We're talking about profiles. That is, you can define a safety profile that allows certain things and outlaws certain other things. We can talk about ranges, we can talk about dangling pointers, we can talk about overflow, we can talk about time constraints. I think we list about 10 to 12 different potential profiles that people have been talking about. And this is not all that different from, for instance, what's done in Ada. That is also a language for highly reliable stuff. And I think we're very close to being able to use some of the standard default, the core profile, which says that you don't break the type system in any way. Very close to doing that with the static checkers. So we're basically similar to languages like Rust in terms of what guarantees we can provide. Rust is a bit ahead in terms of what you can do in concurrency, but there's work with C++ in the area of Mistra, and together with the core guidelines for going in that area.
Thanks for that comprehensive answer. You've touched upon many things that we will actually elaborate on later. I want to focus a bit still on the design. By the way, if anyone is interested in the history of C++, I mean, there's probably many resources, but your interview with Lex Fridman 3 years ago is a fantastic one, by the way. It's a more than an hour-long episode or interview, and it goes through many of the things that were in your head and eventually the committee's heads and the design of the language, and it's beautiful. But before we move on, I'd like to focus a bit. And by the way, I also know that you and the language C++ is taking a bit of an unfair bashing because many of the unsafe low-level constructs are inherited from C and that mythical language that doesn't exist, or the combination of both. So I understand. Let's actually make that difference that C++ is a
Let me say something about right there. One of the things that the core guidelines do is to use the subset of superset technique that I actually popularized. The idea is that you build a support library so that you have a more ideal language. And once that is done, you can cut away a lot of the complexity that you would otherwise have to deal with. So for instance, when you have span, you don't need pointer manipulation in essentially all code. And that way means you can analyze things. The other thing is that you mentioned these quotes people have about vulnerabilities in C/C++. First of all, they're mostly C or very C-style C++. It's not something I have recommended in the last 20 years, but people have been doing it nevertheless. And furthermore, some of these things are outdated. They're old stuff. Buffer overflow, range errors is not something you see in a well-run C++ shop every month. I see them sometimes in testing, but very rarely deployed. But if you take a 20-year-old C++ program or 15-year-old and compared it with a re-engineered
that's true.
piece of code in just about any language, you will find that there's many more vulnerabilities in the old style code than there is in the new language code. If you have new C++ code, you wouldn't have those vulnerabilities either.
That's absolutely true. And although that actually highlights another problem of software supply chain in general, and in the case of C++, of the way C++, modern C++, so the new versions, and I'll let you explain how the committee works and how the rollout of C++ 23, the next one, 20, 17, 14, and so forth, has worked to the ecosystem, the community, and the end user. But before we move in, I'd like to make another sort of like, I'd like to force you to explain a bit. And again, you are representing a consensus-driven committee, so I'm not making you obviously responsible for any of this, and you're not the official spokesperson, but I'd like you to clarify. One of the core tenets of C++ is, as you say, don't break the type system, but another one might be that it is designed to have unbounded, undefined behavior, which collides the idea of that existing as a principal feature of the language might collide with security in general, because you need to a completely secure system might need to have all behaviors defined. So can you elaborate on the collision of those two things, if I have explained them correctly, and if there's a solution to that, Koro?
I think the phrase you used, unbounded, undefined behavior, is to be avoided. It sort of crept in when compiler writers in particular saw lack of definition of something as an excuse for optimization. We just have to get rid of that. One of the things that you can do in a profile is to say certain forms of optimizations based on undefined behavior is just not allowed. It's not that hard to do. And then if people want these ultimate optimizations, they would have to have a performance profile, which would be unsafe in that sense, might be unsafe in other sense. But if you're running in a closed environment, that may be what you want. One of the profiles will be old-fashioned C++, because there's a few billion lines of code out there that needs to not go away, because if you just ban it and ban further development of C++, further use of C++, those lines will be there and they will not be improved. You can wait for replacements to turn up, but you're going to wait for decades.
You probably have better data and more updated data than I do, but the last time I checked, we were talking about almost 20% of the world of the code in the world is written in C++. I think 90%, 19, /20. And I think I quote you from the podcast that I mentioned before, I think 4 to 5 million C++ programmers at the current time. Are those figures?
First of all, I can't count, and I don't think anybody can. And anyway, I have been corrected for that number. People say 6 or 7. And again, how on earth do you count? I don't know. So statistics is not my strong suit here, because I don't think it's all that relevant. It is humongous. It is something that just won't go away. And one of the major problems that I'm trying to deal with, together with Gabby, is now, once we get a number of profiles, hopefully with the key one standardized so that you can rely on it on every implementation in the same way, but you have multiple profiles. Every realistic program for a long time has parts that we can call safe by one of the definitions of safe, and it will call stuff that isn't, or follow a different profile. And it will be called by code that are written with a different profile that could be stronger or weaker in the safety area. And information is being passed along. How do you merge different profiles? That is a big question. And it's a big question not just for C++. If a Rust program calls a C++ program or a C program, heaven forbid, then you have all the vulnerabilities that you are talking about. If it is called from a C or C++ program that doesn't obey the safety rules, the information coming across that interface is going to be a potential problem. And so the composition of code in different languages, the different profiles in a language, is a major problem. and it will last for decades because the code, those billions of lines of code, will not go away.
Before we move on to how C++ works as a language, as a community, as an ecosystem, and then onto the solutions to harden C++, the ones that you propose, others, I'd like to address another adjacent topic to the one that we just addressed, the memory safety, the design of C++, types not being broken and stuff like that, which is, I guess, I would call it developer experience. I know it's a fuzzy and trendy word, but one that actually addresses one of the problems that I think that C++ has, that it is intrinsically complex in its syntax and maybe its verbosity. So I'm guessing, is it true? Would you think that becoming proficient at C++ is actually tougher or way tougher than it is to become so at JavaScript or Python, to mention other two?
Sure, of course it is. C++ is aimed at harder problems. It is creating a foundation. I mean, take Python. If you do a bit of linear algebra in Python, if you did it in pure Python, you'd be welcome, but you would be 70-some times slower than the equivalent C++. And the way they solve their problems, they call C++. The JavaScript engine you're using will be C++. They have outsourced the hard problems to C++, and we've managed rather nicely. So somebody has to do the hard job, and there's a large and growing C++ community that's doing that job. And there's new hardware coming. You have to adapt to it, new forms of concurrency. You have to adapt to it. Somebody has to do it. You can not say, okay, well, ignore this, then everything gets simpler. That doesn't work. Now, there's another aspect of complexity, which is all of these old-style coding and old-style techniques and endless ways of fiddling with pointers, etc., etc. Yeah. And my solution to a lot of that is, well, it hurts when I hit myself in the head with a hammer, so don't do that. And how do you make sure that you don't do that? You have a static analyzer that keeps you out of the dark corners. I mean, the core guideline says don't do address arithmetic. That has been outsourced to a library. Exactly the way that other languages simplify.
But that actually, I mean, and we will get into the enforcement of the core guidelines and how actually the ecosystem, specifically the tool providers, static analysis, dynamic analysis, all the different tools that might help with this, adopt that. I think that's a big problem that maybe regulators can help with. But yeah, staying on the developer experience topic, you say that you codify that in a library, but again, isn't that adding on to the cognitive load of an already complex language that I need to bring this dependency here and keep in mind that this might be updated and might break changes and so forth. So again, I'm not trying to convey the idea that C++ should be just straightforward, like HTML, like literally you could read natural text and you should. But yes, I guess could the developer experience of C++ be improved by changing things in the way coded the core guidelines or the language itself is actually distributed?
So there are two things we need to do, and I'll explain it like this. At least twice a month, somebody comes to me, usually quite emotional, and says, C++ is too complicated, you must simplify it. I said, yeah, it's too complicated, we have to do something. And while you're at it, you must add these two features. I need them yesterday. Yes. Oh, and by the way, don't break my code. I have 2 million lines of it, and you mustn't break it. You can't do all of those three things with a language change. So my solution is we stick to a very strict notion of compatibility. We don't break code. It's not 100%, but it's 99.99, something like that. But we can simplify use. And that's where the core guidelines come in and the work there. Basically, you don't have to get into the dark corners. The language that you write in when you're using the core guidelines is fundamentally simpler. I'm working on a textbook now, revision, and I'm finding that essentially everything I do fits into the core guidelines. So you could have a textbook for novices that fulfills all of these criteria. And it comes out quite naturally. I didn't try to fulfill the core guidelines. It's just that the core guidelines are a bunch of good ideas. And when I have to teach how to write code, you use those good ideas. We'll see if this works out, but I'm working on that. There are a lot of programmers that says, well, I want to know everything. I want to be the expert. I want to know absolutely everything. And I usually say, well, if I had to remember everything all the time, I would be a much worse developer. I would write worse code. I would be spending all my time trying to be a language lawyer. I know language lawyers. I can be a language lawyer when I have to, but most of the time I want to be a programmer. I want to be a developer. And for that, you try and say, how do I say what I want to say the simplest possible way? And then I want to codify that and have a checker that makes sure that when I screw up, I get caught.
Last question that I have around quote unquote developer experience. And this is less about the individual contributor and the cognitive load of...
One more thing here.
Yeah.
I'm working on a book. This is my explanation for people who wants to know what modern C++ is. And anybody who comes and says, well, it's a dialect of C and you have to learn C first, they should read that one, because that demonstrates that that was not the idea, and it is not the idea, and it's not a necessary way of looking at it.
When is that revision coming out, by the way, of the book?
Oh, it came out half a year ago.
Okay. Last question again. Not so much focused on cognitive load of the individual contributor and the individual C++ programmer, but actually team software delivery, right? And this is mostly a factor that I would like your opinion on. It seems to me, I don't have strong data about this, but I do have proxies and kind of anecdotal evidence of it, that most of the C++ programming and teams out there programming in C++, and especially those focused on safety, are using waterfall, V-shaped methodologies, all these kinds of old, and they are not adopting continuous delivery, XP, or test-driven development. So is there a fundamental design in C++ that would actually disable or become provide too much friction to adopt these methodologies that, as you said at the beginning, are meant to cut down feedback loops, feedback mechanisms, so that you can launch code in production and receive feedback from the end user, and therefore, chunk down the amount of code on ideas that you ship into production and make it more secure, more performant, in shorter feedback, in shorter time. So I wonder if this reality that I just described is actually true in your view, and why would this be specifically the case for C++?
I don't claim to be a tool chain expert, and I'm not in sort of a situation of maintaining a tool chain for others or a salesman of such. So I know something, but mostly like your average developer, and maybe even worse than that, because I focus on teaching and design and helping others. So with that caveat, I think that some of the tool work is there to compensate on people doing really old-fashioned stuff. Some of the analysis, some of the dynamic testing, some of the test driven stuff is there because they don't have a type system in place, or if they do, they break it all the time. It's
Okay.
driven by weakly typed languages, and my approach is very explicitly and deliberately. It's meant to be strongly typed. It's meant to be enforcement of strong typing, and that is the main tool for getting out of it. In other words, I'm looking at static tools and using static tools to place dynamic checks in the code, as opposed to writing dynamic checks that you can dump into the code, that you can by tools insert into the code, that is inherently unsafe and
Yeah.
inherently messy. Um, it's a different approach. And yes, there's a lot of tool stuff that needs to be put in place. And the tool builders have to realize that they shouldn't do C first for everything they build. They actually have to use the type system of C++ to get the benefit of the C++. And that is not easy to convince them about.
Oh, why
Um,
so?
because they see that there's this much C, there's this much C++. Well, C++ is sort of like C, so if we do it for C, both can use it. So why do only half or three quarters of your community if you can start with the other quarter? Um, my information says there's significantly more C++ in production than there's C, and that's interesting given what you see on various news sources. But yeah, there's something I was
So,
going to say, but I've lost the thread now.
so would you say then that it is feasible to do extreme programming, continuous delivery? Again, I'm not necessarily focusing on one of these agile development, anything that shortens the feedback loop with the end user and that actually reduces the amount of code released each time so that that virtuous circle happens.
If
Is
that's
that possible to be
if that
done with C++?
yes, if that's what you want, you can get it. But I have a strong suspicion that a lot of sort of continuous this and move fast and break it and agile and such leads to a short-term focus that doesn't allow you to address fundamental issues and actually increases the bug load. In other words, the insecurities.
Yeah.
So if you are working on high reliability stuff, you actually have to take it a little bit slower. Slow down, think the problem through, express it carefully, do a fair bit of testing of various sorts before you ship. You do not want the brakes of your car or the control system for your
Yeah.
airport to be written and uh, updated by relatively cheap developers with a short-term perspective. One of the things that I worry about a lot in sort of my other hat with education is that people think that programming is one thing. It isn't. There are styles that work for doing a web app, and there are styles that work for engineering a control system. They are not the same skills, and I don't think it should be the same tool chains. I don't think it should be the same style of language use.
Yeah, I do agree with you. And then my mind goes to why would government, in this case, the American government, or the National Security Agency, maybe not the full, it doesn't voice the concerns of all the government, but also the EU. The EU has put out what seems to be a template, a draft of a new law, a new act called CRA, Cyber Resilience Act, which is pretty undefined as of now. We're recording this in March 2023. But yet it seems like they've run out of patience, and they are putting pressure on the software suppliers, among which could be the creators of programming languages, to harden their output. In this case, C++. So let's move on to how is C++ hardened and the future of C++, which is something that you've already described here.
So as I said, I have been working on this, depending on how you count, for 7, 20 or 40 years, slowly improving things. And people say it's too slow, but it's really hard to move at the scale we're moving at. And I'm encouraging more pressure to be put on safety. Safety and security are not the same thing, but putting more emphasis on that would be good. I think it is unfortunate and ill-considered to focus on this language is good and this language is not good. I noticed that the people listing good languages don't list Ada, which is probably the best language for
That's true. They don't even mention it.
They don't mention it. And they pick on C/C++, and I think that is unfair and unfortunate, because it could actually turn the C++ community away from that, whereas they should encourage the C++ community to pay more attention to safety. And given that I've been working on type and resource safety for years and documented and have static analyzers in the field and such, I could use some help.
True.
And the Standards Committee is a very large, very diverse group. It is very hard to make them move in one direction. Take a photograph of the people that voted in C++20, a superb piece of work. You see 250 people cheering. How do you get 250 people to agree on anything?
Yeah.
That's not easy. And we got very important things for both the development experiments, like the modules that speed up compilation with 5-10 times, not a little percentage, and also removes a whole bunch of error-prone facilities related to the very old composition of code with includes. We got what's it called, concepts, which will make generic programming safer and simpler. People would just learn that that's what they really want, because that's the same thing as you get for static types in normal code and overloading. You get it for generic code now. We got coroutines, which give us speed and also simplicity of what otherwise would be complex systems. That's a major, major improvement, and people should move ahead of that, and it will get them towards the goals of type safety and resource safety.
I would personally encourage the NSA, in this case, who put out that announcement, and the European Parliament stakeholders to engage in conversations with the committee, with the standards committee, because otherwise, without this collaboration, it's just pointing fingers.
We were not contacted. Nobody went to them. There was a lot of people working on Rust, a lot of people working on some of the other languages mentioned that says, oh, and by the way, these are great languages, give us money. Wait a minute, what is this? This is self-dealing.
Yeah.
I would have been happier if there had been some contacts, and I believe that some contacts are being made. But again, they mix up C and C++, which in this context is not a good idea.
So let's help them, actually. And this is the final block of the interview, in a way. How are you and the committee, the standards committee, working on hardening C++ and, getting to that sort of like compromise between safety and security and even speed, I would argue, speed of releases, rather. So there's I think the, as compromises are, they're almost impossible to solve, but, I think that gradually we can get to a best practices solution or something.
Yeah,
So there's
wait. I think compromises is the wrong word.
Yes, it's how would you call it?
Type safety is a thing, and it's concrete and it's provable. If I can define an object of type X and use it without going through the interface of type X, it's broken. And so this is not something I'm interested in compromising about. And I think we have an approach that might work if people realize it. This is the profiles approach that allows you to get a variety of things. So what you get is not a compromise between this and that. You can get this or that, as is appropriate. The other thing people should realize is that you can't do this by patching without a framework. And that's something that's going on in the committee just now. People say, I have this great thing, this will improve it. And it might improve it, but there's a cost. And does it fit with other things? And so I'm trying to get people to work within the framework of profiles and also work within the framework of the type system, as opposed to saying, I can hack this into the lower level of the system where types doesn't exist and where we've got a lot of macros, and it works with C2. It cannot be complete. This is not the way you go. So I have an opinion, you could say an attitude, which is basically type safety is good. I learned this. If you go back and look at my writings from the 80s, that's what I'm saying. That's what the aim is. We're going to get there. I remember talking to Anders Heisberg that went and did C#. And I was saying this sometime in the 80s. And he says, but it's going to take years. She says, of course it's going to take years. It'll probably take decades, but we have to get there.
So let's actually help the public servants that have probably, that are willing to engage in conversations and collaboration in the open source spirit with the C++ community, right? Let's help them see where modern C++ is going, right? So it seems like there's the way things are modernizing, and this has been happening for a long time, it's not that this is new, is in three ways. And let's actually touch upon the three of them. One would be the core guidelines. You've mentioned it, so I'll allow you to elaborate on that in a minute. MISRA, you've also mentioned that, how those combine and so forth. The standards, and I'd like you to describe a bit at a high level, how does the C++ programming language standards committee work? The working groups, and how the new versions of, version might not be a good word, of the language come out. And the third item that I think is modernizing C++, so core guidelines, the standards, and the new rollouts of the new version of C++. Again, say if version is a right word. The ecosystem, right? Because those two remain a bit in the ideal, in the realm of ideas, but then need to be enforced. And it's eventually the compilers, it's eventually the static analysis tools, the linting tools, the parsing, all those that eventually implement those things. So let's focus a bit on a summary description, high-level description of how the standard works, the standard committees works, and the new releases of C++. The next one being 23 in this year to be rolled out. How does that work? Okay,
so for good and bad, the C++ Standards Committee is a very large committee. 200 and some people turn up at meetings. maybe 500 is involved in total, at least 400. And it's hard to get a coherent design out of that. On the other hand, it is hard to ignore real world problems. We have about 20 countries involved here, and all the major companies, a lot of small companies. And it's organized in a somewhat bureaucratic manner, which drives me nuts, but it's probably necessary, which is study groups. We've got 20 of those that study particular areas such as security. We've had it for a while, such as databases and such. And then that feeds into 4 groups, working groups that consider concrete examples, which then gets into a plenary where they vote again. There's votes all the way down here. And then once we get a document to put together, a new standard, it goes out to the countries for ratification. Okay. And we have to work slowly because 2 or 3 countries voting no would kill a standard. This has never happened because we work till we know everybody have agreed, not that it's perfect, but it's at the best they can likely get now. And so we get votes like 22 to 0. That's where we go. The technical consensus is more like 85-90%, but it's up there. We don't want something like, say, the UK vote, where they 52 to 48 decide to commit.
Thanks for bringing that up.
Yes,
but yeah, it seems to me that the design of the standards committee, so study groups, 20 roughly, 4 working groups, then that pours down into actual contingent proposals that get voted by all the committees, and it's consensus driven. I would argue that compared to how JavaScript is developed, released, updated, Python, and it seems to me that, and without going into detail into how that works, it seems to me that this is a very representative, for lack of a better word.
It's a more representative, more democratic observation. But then
I was going to say democratic.
The dictator for life resigned because it was too difficult, and there's been other of those committees that are closed. They have the benefit of a dictatorship. You can do things fast, but then power corrupts and all of that. One thing that this system of committees doesn't do well is to maintain a coherent direction and come up with coherent proposals that are uploaded. And there's a constant tension of how the proposals are built and then how they move through this system. And one of the things I'm doing with my profile proposal, which, by the way, got something like a 22 to 2 vote for a framework at the last meeting, creating a framework and then having individuals, usually smaller groups of individuals, coming up with designs. Concepts was the work of Gabby Does Race and me, for instance, and I'm blanking out a couple of others.
Oh, no worries.
And so also we got 23 voted. It has voted. It is going to the national votes and it'll pass. It's a fairly minor extension. If you look at 20, you get a good idea of what the big framework is, but we have the feedback. We've plugged the little details that we couldn't get right without trying it at scale and without integrating it. Feature interaction is a really hard problem in a large project, independently of what we're talking about. And so that's what 23 is.
So, by the way, so before we move on to core guidelines, which I mentioned and you actually mentioned before, and the ecosystem, the C++ industry, compilers, dev tool providers, and so forth, let's focus on four of the proposal to dovetail a bit and focus a bit back again into safety and security. Let's focus on four, and hopefully you are aware of these proposals because they are bleeding edge. I mean, I think some of them that I will mention were proposed to the committee 2 weeks ago, 3 weeks ago. I can't remember when was the last meeting. It was very recent, correct?
Yeah, that was in
a month ago,
early February.
I can't even pronounce where it was, the place. But anyway,
outside Seattle.
So again, the pressure from the NSA, the EU, the industry in general is actually being carved into proposals. So there's one, for example, that is actually one in which you have an opinion. You actually delivered an opinion, which is bringing Rust's memory safety into C++. That sounds simple. It specifically talks about... No, it's not your proposal. I'm saying that you had an opinion on this proposal or on this idea. Apologies. The proposal is from, I can't remember, but I'll link it in the show notes. I've got names for everyone, the proposals. Thomas Newman is the next one, JF Bastian, but I forgot about adding this one. I'll add it to the show notes. How would you see porting, quote unquote, porting the borrowed checker from Rust into C++? Would that work in your opinion, or is that an idea that would not work?
Curiously enough, I invented something like that back in 2005 or something, and I never implemented it. I looked at what it would do to key programming styles in C++ and decided it wouldn't fly. Okay. And maybe it will today, but I really doubt it. And these proposals are the ones that are coming. I've got a great idea that can help. And it might help, especially in some area, but not in others. I want memory safety, and I can get it, and I am getting it today. I don't need the borrow checker. Now, if you want to deal with the concurrency issues where there's interesting things like if there's only one pointer to something, then you don't need a log on it. That can be done with very minor tweaks to unique pointer and enforcing some of the rules for what a sane destructor is. I think a lot of people seem to have discovered security and safety issues very recently and are rushing with the obvious first ideas. And we need to think harder than that.
What about the next one, which I already mentioned? I think it's Thomas Newman's proposal, which is basically roughly to add annotations, if I'm not wrong, to mark aliasing, lifetime or dependencies between objects.
It doesn't scale. It's been tried many, many times in industry and academia. It looks beautifully in a paper. It looks beautiful in a small program. It doesn't scale. Once you have thousands of annotations, some of them are getting wrong. You need a framework so that you can actually verify the annotations, so that the annotations become optimizations. So, for instance, I propose an annotation for non-invalidating functions. That is, when you call a function on some data, it might invalidate other references to it, and that's banned by static analysis done today. We're not hypothesizing here. But there are some functions that, by their type signature, could modify the data but doesn't. Actually, quite a few of them. So I want an annotation that says non-invalidating. This has the interesting property that it makes it very easy to make sure that you can use that function, but it can be validated when you define the function fairly easily, locally. You just see if it does it. For an individual function, static analysis can do that, and the rules for local static analysis, which what we're talking about, global static analysis doesn't scale. It has the interesting property that either you can validate it's correct, you can validate that it is not correct, that's easy, or you can say it's too complicated to provide a guarantee. and that's fine. You just can't call that function under the guarantees if it can't guarantee to follow them.
And we're moving now on to your proposal, yours and several others, Ali. Does that fuzzy, you said, so you said that static analysis would provide a binary answer, yes, it's okay, no, it's not okay, or that middle ground. Does your core guidelines enforced in a local static analysis tool actually help with that fuzzy area?
The core guidelines.
And please explain what they are, by the way.
Okay, yeah. The core guidelines is a set of guidelines supported by a set of enforcement rules, and those enforcement rules are implemented by some static analyzers. We need more than that. If you look at my proposals, that's exactly what I'm saying. We need to tighten up the core guidelines so that we can standardize the core checking, and in that case, the middle ground becomes if you're on the middle ground, if you cannot prove it is true or false, then it cannot be called, but it's a useful tool. It tells you, the developer, that your code is too complex to give an answer. And then you might consider things like a non-validated annotation or something like that, but you have to minimize annotations. As soon as you start counting them in a large number relative to the number of lines, it doesn't scale. This has been tried again.
This, by the way, should be reliant on sort of like intelligent developer tools, right? Not only static analysis, but maybe IDEs, right? So that the core guidelines, and I'm thinking maybe of ChatGPT. I don't know. I'm just mentioning the fact that helping the developer make a decision, when he reaches this endpoint in which the core guidelines or the implementation of them are telling him or her that his or her code is too complex, then he or she might need help. And that's why what I'm asking, is this tool providing the core guidelines suggestions intelligent enough to provide this specific help that this person might need? Because otherwise it might be...
The core guidelines was designed to be helpful. The problem is that the resources have not been available to build the tools that could be used. One of the rules is that if a core guidelines prohibits something, it must always provide a suggestion for an alternative. This is in the ground. It's right there from the beginning. And the imagination we had at the time was that if a guideline is violated, your IDE comes up flashing, this is where the rule is, it's got a name, it's got a rationale, it's got an example, and if it prohibits something, it shows something about how you can do it otherwise. On the other hand, I don't want to the smart tools to do more than help you. I don't want them to provide guarantees. The guarantees should be in the type system, in the rule sets. And there was some examples with supporting tools that help people write code, and they actually found that people were making more security violations than if they had to write it themselves, because they relied on tools that weren't perfect, and they their brain turned off a bit because they got so much help. So I think you could have all kinds of help in the IDE, but the guarantees has to be provided by some tool devoted to enforcing it. Can't rely on people following the rules or even the tools can do it. There's been a lot of model-driven development, and they tend to have a lot of options. And people use a variety of options. And then you wait 5 years and you wonder which options they used and which guarantees they really had when the tool have changed and the world has changed and the libraries have changed. No, I think we need a good solid foundation, and then we need the help to be built on that. Separate the two.
Last question about the core guidelines. How do they sit within the standards committee itself? Are they? Where do they sit, and what are they?
They don't fit. They are an individual activity done by a handful or a couple of handfuls of people. They exist. They are on the web. They are available. There's books about it. There are several static analyzers that use them. There's libraries that support it, but it's not standard. And some of the parts are coming into the standard, and sometimes the standard is weakening some of the guarantees that was provided because these guys aren't as focused on safety as, say, I am. But we'll see what happens. The profile proposal relies on something like core guidelines, but it isn't core guidelines. It is stricter and hopefully standardized. The core guidelines have rules to make it simpler to write code. It has heuristics-based enforcement, which we can't have for the safety-related stuff, but we can have it for other profile that says, how I would like very much a teaching profile, which basically shows you a simpler language that stops you from getting into the dark corners.
Yeah.
I don't think that'll be standardized. I think it'll have several heuristics in it, and it'll be very, very useful for getting people on board with a modern style of coding.
Yeah, that would be actually really interesting. So last of the three sort of like ways in which C++ modernizes and, as a result of that, is hardened and made more secure. And there's this relationship between the release of new standards, again, the latest one coming out when, by the way, sometime this year?
Sometimes this year. It's being voted by the nations just now. It should be there in the fall sometime. It takes forever for the nations to agree on anything.
I can see.
They will.
Anyway, just let's use 2020, C++ 20, the one rolled out in 2020, for reference. How does the relationship between the propagation, the existence of a new standard and its propagation to the tools, right? Again, it's this idea that the standard library is a great, the latest and greatest of C++, and yet it will not be successful if it's not implemented in the tooling, in this case compilers, but elsewhere. So how's that relationship?
But they are. Today, C++ 20 is very close to completely implemented by all the major implementers. And parts of C++ 23 are already deployed. I use as a default compilers I use the latest switches so that I can try out the new things. And I'm using C++ 23 features today. Oh. Now, if you want to know where the world is in those respects, you go to cppreference.com, which is one of the best online documentations of C++, and you look for the compilers. And then you have a graph of a table of all the features and all the compilers that shows which stage of C++ they have implemented. And you will see that here red means it's done, or maybe it is, or maybe it's green. But anyway, most of it shows it's done. And they are almost complete for C++20, and they are maybe a third of the way into C++23, and I
Wow.
expect them to hit close to 90% of C++23 before the end of the year.
So I guess, and this is probably the final question, unless you consider we didn't touch upon anything that you wanted to touch upon. But how can the Standards Committee, the working groups in it, but the Standards Committee, the ecosystem, meaning the industry, the compiler providers, the dev tool providers, and the public powers, the NSA, if they want to get involved, the European Parliament, or anyone that has actually called upon C++ to become stronger, or safer rather, securer rather, how can all help bring legacy code, in this case C++, legacy code base, to the most modern and therefore secure version of C++? Is there a way in which, all these three actors and agents can help make the enormous amount of C++ written out there, 98, you name it, old versions of it, come to date and become more secure?
I mean, upgrading old code is very hard because old code is messier, and really good developers would rather work on something much more modern and elegant and such. And so we are going to look into the situation of upgrading the things that has the greatest needs first, in terms of safety, for instance.
Yeah.
And so basically we have to choose areas where we put our efforts. And some of that will have to be rewritten, some of that will be modified. A lot of that work can be done by switching to more modern libraries, and some of them are in the standard. Some of them can be done by injecting supporting code to support the type system, not random testing of memory locations. There's also that, but people are doing that. That is not my approach. My approach is to, I would like to be able to throw a switch that says the resulting program will be completely type and resource safe. No leaks, no type violations. I think I know how to do that. It would cost some money. If somebody was willing to put the effort in, the public, etc., should think about this.
Yeah.
One of the things C++ never had was money. We don't have development money for the language itself and for the fundamental tools. We have a handful of compiler writers, and they are not a profit center for their organizations, so they are always short of money. We have several handfuls of good library writers, some of them dealing with the standards. But again, we are at the foundational end of things, and that's not where the commercial organizations like to spend most of their money. And so if the if the public servants decide to be helpful as opposed to just saying don't do C/C++ and try this new untried language, not even standardized, it has no formal definition, but go to it, it's safe. Give me a break. Anyway, but if they want to be constructive, say that we would like to give some benefits if you deliver things that are demonstratively type and resource safe.
I can see.
Encourage Microsoft and Facebook and Google, and IBM, and such to do this, not by going and doing something brand new that doesn't apply to their existing code bases, but something where you can take your critical software, upgrade it, and then go to the next most critical one, and build your new stuff so that it fits.
Yeah, I personally think that a detailed assessment of the C++ software supply chain, again, considering these items, these agents rather, the committee, the compiler developers, the SaaS developers, all the dev tool developers, and the end users, and addressing the financial bottlenecks in each one of those. If we consider C++, as it seems that we are considering globally, a critical element of the software supply chain in general, would be ideal. I would argue. It is. No, I know. That's why they made such strong statements that I quoted at the beginning of this.
Some of those statements, they're right in what the problem is, but their solution is half-baked.
Exactly. That's what I'm saying. It's missing the other side of the coin.
If they want to encourage the standards committee, that would help me a lot. I'm having some trouble convincing everybody that they should actually focus on the fundamentals, on the safety things, on the simplification. These guys are mostly technical experts in some area and really want to see their area become better, which means more facilities, more tuning opportunities and such. And that's not the whole thing. We need to be able to focus on the safety and that's type safety and resource management.
Yeah.
The profiles, by the way, allows you to do both, because you can have a performance profile or a low-level hardware profile, but it's different from the, say, type safety profile.
What arguments are you finding against profiles?
I don't find arguments. They all love the idea, and then they go and do something else to a large extent. I was deeply shocked. I had I think it was 42-2 vote. This never happens. I mean,
could this be related again to the cognitive load / developer experience of it all? That it is a nifty solution that solves the problem, but one that involves a ton of work.
Yes.
That's why I think developer experience is fundamentally...
You want to do something that works on a world scale.
Yeah.
I mean, people come, and I've seen examples, you say you should do this, and says, it's been done. I did it for Pascal 10 years ago. Yeah, but I needed to work for million-line code bases, multi-million-line code bases.
Yeah.
I need something that can be distributed worldwide, or to Mars, if that's where your code is.
Yeah, true. Well, Bjarne, I think we've covered everything that I at least wanted to cover. Did we miss anything that you wanted to talk about security?
I'll just again say what I probably have said 10 times already. We need better support for type safety and resource safety, and we know how to do it. And the framework for that are the profiles, and we need support for that. Anybody who can give support, moral, verbal, financial, for this, they can do something good to the world.
Indeed. Well, with that, Bjarne, I'd like to thank you for joining us today at Software Engineering Daily.
Thanks. I hope this has some good effects.
It will.